Hey students, let's work through that 1, 2, 4 circuit calculations. So I'll bring up my piece of paper, and I want to look on the other screen here to see the problem. So the first one starts out very easily. I'm going to go ahead and draw in my V, I, R, so we can use that as we do these problems. So now I have a simple circuit with a resistor. That resistance equals 470 ohms. My voltage equals 3.5 volts. And I want to know what current is. Okay, so I'm solving for current, put my finger over the I, so it's I equals V over R. V over R. And voltage is 3.5 over 470. And then you multiply that out, and I'll use the calculator. And let me bring it up on my computer. 3.5 divided by 470 is I get I equals 0.0074 amps. All right, and we can move that decimal place 3 to the right and get that the current is 7.4 milliamps. Okay, the next one is same deal. Current is going to be equal to 15.5 microamps. Voltage is going to be equal to 3.5 volts. And our resistance is something. So we're solving for R, so that's going to be V over I. So R equals V over I, voltage over current. Our voltage equals 3.5 volts. Current is, now we have this in microamps, we need to convert that. All right, so the way I normally do this is I just write out a bunch of zeros, and then I'll put 15.5, right? And then I will move my decimal place, and micro is 6. All right, and you can look that up by looking up metric prefixes. So there's where it is normally. 1, 2, 3, 4, 5, 6. Oh, look, I did that the exact number. All right, so that's the number we're going to put into our calculator. So 0.0000155. 3.5 divided by 0.0000115. And let me hit that one more time. 3.5 volts divided by 0.0000155. There we go. I typed it in wrong the first time. So then that gives me that the resistance equals 225,806.45, so we can say 0.5 if you want to say that. All right. The reality is there's no resistor that is 225,806 big, so you'd round that up, and so really the resistor is probably 230,000 ohms. That's as big as you are going to be able to, you can only purchase things with a round number. Okay, and then the last one, we have current equals 1.4 milliamps. I've got voltage equals I don't know, and I got resistance equal to 22 kilo ohms. Okay, so we need to change this one and this one into plain ohms and plain amps. Okay, so milliamps is move it 3, so I can again write my I is equal to just some zeros. All right, here it is, 1, 2, 3. So that's going to be 0014. And then kilo ohms is move it 3 to the other way. And so this is going to be 22,000 ohms. Okay. We're solving for voltage. Voltage equals I times R. Voltage equals 0.0014 times 22,000. And if I do my calculator, 22,000 times 0.0014, I get voltage equal to 30.8 volts. Right? And if you want to round that to 31 volts, that works too. Okay, so that's the 3 easy ones. And we will go ahead and do the next one. So the next one is, for each of the circuits shown, calculate the value of RT. Be sure to put your answer in proper engineering notation and correct units. And so let's draw it out. So we have a battery. We have a resistor. We have another resistor. And we have a third resistor. All right, and we want to know what RT is equal to what. Okay, and this is 150 ohm. This is 1.2 kilo ohm. We can rewrite that as 1200 ohms, because that's the one we're going to use. And 820 ohms. 820 ohms. Resistors in a series add. Okay, so we have RT is equal to R1 plus R2 plus R3. RT is equal to 820 plus 1200 plus 150. And so if we take that, where's my calculator? 150 plus 820, I started on the wrong end, plus 1200. So I just added these 3 together, and that leaves us RT is equal to 2170 ohms, right? Or, because you can't buy a 2170 resistor most likely, and then that is probably 2.2 kilo ohms, right? It's probably 2200 ohms. Right? The other one's a little bit more complicated. All right, we have our battery over here, and we have 3 resistors. I'm going to draw it rough. All right, and I've got 5.6 kilo ohm, which is 5600 ohms. I've got 680 ohms. And I've got 8.2 kilo ohms, which is 8200 ohms. Okay, and so with parallel circuits, you take the reciprocal of the reciprocal, so that is 1 over R1 plus 1 over R2 plus 1 over R3. Okay, and so then what we need to do is say 1 over, and those are added, and that is going to be 5600 plus 680 plus 8200 And if you put that into your calculator, you'll get 1 over 1 divided by 5600. That gets us to 1/8 to the -4. 1, 2, 3, 4. So 0.00018. All right. 1 divided by 680. 0.00147 plus 1 divided by 8200. 0.0001219. Make sure I did that right. 1, 2, 3, 4, because my calculator gives it to me in scientific notation. So then I'm going to have that number plus 1.00147 plus 0.00018, and that gives me that, and I can memory store it. That gives me 0.00177. Memory store 1 divided by memory recall, and that gives me a total resistance equal to 564.3, which is probably a total resistance of 560 ohms, which you can now see. Okay. So that's that one. So let's go ahead and clear my calculator. Let's go ahead and work on number 3. Solve this circuit for basically everything. Okay, so I've got a circuit. It's got a battery, and it's got 3 resistors. It's got 470 ohm, 1.2 kilo ohm, which we can write out as 1200 ohm, and it's got 270 ohm. All right, resistances in a series circuit add, so RT is equal to R1 plus R2 plus R3, which is equal to 470 ohms plus 1200 ohms plus 270 ohms. And that equals 470 plus 1200 plus 270, 1940 ohms. All right, which you could probably go ahead and round to RT as 1.9 kilo ohms. All right, but we're going to use this for all our calculations. Okay, we know in a series circuit that total current is the same. So current at 1 is equal to the current at 2. That's not a plus sign, that's an equal sign, which is current at 3. Okay, so if we solve for IT, then we're going to go ahead all right, we're going to solve for current, so it's voltage over resistance. IT is equal to voltage total over resistance total. Voltage total is something I didn't write down. That's 9 volts. So 9 volts over resistance total of 1940 ohm. That's going to be, I got that still in there, so I'm going to memory store that. 9 divided by memory recall, and that's going to give me 0.004639, or 4.6 4 milliamps. Then we just need to solve for voltages at 1, 2, and 3. Voltage at 1, voltage at 2, voltage at 3. Voltage is equal to I times R. Current's going to be the same, so we can write 4.64 in each of these. And then it's going to multiply out by resistance. So we'll put in 470 ohms, 1200 ohms, and 270 ohms. So then my voltage at 1, voltage at 2, voltage at 3, I'll write it to the calculator. I'm going to memory store this number here so it's not rounded. And I'm going to multiply that by 470. And that's going to give me a voltage of 2.18 volts. And I'm going to memory recall that the number before times 1200, 5.567. And again, these are volts. And then current times 270, 1.2526. Okay, and then I can check that with Kirchhoff's voltage law, where the voltage total should equal voltage 1 plus voltage 2 plus voltage 3. Voltage total is 9 volts. That should equal 2.18 plus 5.567 plus 1.2526. All right, and so if I add those together, all right, I get 9 volts equals to 8.999, and that's basically 9 volts equals 9 volts, right? So it checks. And now you can see what I was writing that entire time, right? So voltage total in a series circuit is voltage 1 plus voltage 2 plus voltage 3. And then if I add those three together, they should equal 9 volts. I got 9 volts equals 8.999. Right, so 9 volts equals 9 volts. The whole shebang checks. And then we have the last number, or the last problem. All right, I'm going to go ahead and do my voltage IR. Okay, and it says using laws of circuit theory, solve for everything, right? So I have a series circuit, I have a battery, I have 3 branches with 3 resistors, right? And I have 8.2 kilo ohm, 6.8 kilo ohm, and 4.7 kilo ohm. All right, and this is 12 volts. Okay, so voltage total is equal to 12 volts. I'm going to rewrite these to 8,200 ohms, 6,800 ohms, and 4,700 ohms. So now let's figure out the resistance total. Okay, in a series circuit, resistance total is equal to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. And if I substitute in, that's RT is equal to 1 over 8,200 plus 1 over 6,800 plus 1 over 4,700. And then if I solve for that, take my calculator, clear it out. 1 divided by 8200, 0.000219 plus 1 divided by 6800, oops, 1 divided by 6800, that is 0.0001470506 really, plus 1 divided by 4700, and that is 0.00021277. So we can add all those up. So that plus 0.00014705. Now I'm going to a lot of decimal places because I want it to round very nicely. 0.001219. All right, so that leaves me 1 over 0.0004817116. That's going to equal 1 divided by the number I just said, 0.0004817116. All right, so that gives me a resistance total of 2075.9 ohms, right? And we're not going to use this for our calculation. We'll use this that we just calculated, but our resistance total is probably 2.1 kilo ohms. Oops, I could write that where you could understand it and see it. 2.1 kilo ohms, right? So round that up to 2100, and that's 2.1 kilo ohm. Okay, so now we need to figure out current. Okay, and we know from this, right, that I have voltage total, I have resistance total, I can figure out current total. All right, so current is the one that I am missing. Current total is equal to voltage total over resistance total, which is equal to 12 volts, divided by 2075.9, which is equal to 12 divided by 2075.9. And that gets me 0.00578, which I can 5.78 microamps. Okay, so now all I need to do is figure out current, okay, because in a series circuit, the voltage total is equal to voltage at 1, which is equal to voltage at 2, which is equal to voltage at 3. So I can go and say, all right, the current at 1 is equal to, right, and we're doing current, so voltage divided by resistance. Voltage is always the same, okay, so it's always going to be 12 volts over my resistance at 1. All right, I2 is going to equal to the voltage at 2 over R2, and I3 is equal to voltage at 3 over R3, okay? And then we could rewrite that, I kind of did it here, 12 volts, because voltage is the same, voltage at total is equal to voltage 1 plus voltage, or is equal to voltage 1, which is equal to voltage 2. Voltage is the same everywhere, right? So then we just have the resistance at 1, which is 8200, I2 is equal to 12 volts, 6,800, the resistance at 2, and I3 is equal to 12 volts over the resistance, third resistance, which is 4,700. And then if I do the calculations, I get 12 divided by 8,200, and that gives me a current of 0.001463, which is 1.463 microamps. Current at 2, 12 volts divided by 6,800, 0.001767, 1.765 microamps. And the current at 3, 12 volts divided by 4,700, 0.00255319, which is 2.55 microamps. All right, and if we add all those up, we can check that with Kirchhoff's current law, right, which says that the current total adds up. All right, current total is equal to the current at 1 plus the current at 2 plus the current at 3. Okay, so the current at 1 is 1 IT. Okay, there, in case I wasn't showing it before, there's where I did that. So the current at T, you can pause the video and see that. Current at total, right, is, we solved for that earlier, that is 0.00578, must equal 0.001463 plus 0.001764 plus 0.00255. All right, and then let's add that up. Clear out my calculator. 0.001463 plus 0.0017764 plus 0.00255, and I get 0.00578 is equal to 0.005777. All right, so that is another check that is correct. All right, so I hope this helps you guys. I will see you later.